All right, this is the Algebra 2, Unit 7, Lesson 9 video over the composition of functions. Composition is something that we've already covered in the course. Just to remind you what compositions are. Compositions are when we take two functions, and I'll do an example unlike the ones that we're doing in this unit. Let's say I have these two functions, f of x and g of x, and they tell me that they want me to do a composition, and the way that is going to be notated is like this: f of g of x. If you remember, it means that I'm going to take the g function and I'm going to put it in for the x in the other function. So when I do that, it's going to look like this: 3 with inside parentheses 4x minus 1, where the x was in the equation, plus 7. And then it's just a matter of simplifying. So I'm going to distribute this. Switch colors here. Distribute 3, so it's going to be 12x minus 3 plus 7. And I continue simplifying. 12x plus 4 would be f of g of x. So you see, we've already done this in the previous unit. So that's just a refresher. Please go back. I'll put a link in the video description to that other video so you can review compositions of functions that way. But in this lesson, we're doing composition of functions dealing with the types of functions that we've been working with. So the first thing we need to talk about is strategy. So if you look at the actual lesson, a bunch of vocab there, they're giving us a variety of functions that are either radicals or fractional exponents or reciprocal functions. So one thing we're going to want to do is convert everything into exponents. I don't want to be dealing with fractions and fractional exponents at the same time. I'd like it if they were both in exponential form. So the way that's going to work is I'm going to walk us through, we're going to go through all these problems, and we're going to make sure everything is in exponential functions. So like in this first problem, we already have x to the 1/3, so that one's already an exponential function. But what about square root of x? So we're basically, what this is going to serve as is kind of a guide for you. So for instance, when you have square root of x, we learned in this lesson that that is the same as x to the 1/2 power. So when I do my composition function, I'm going to want to use x to the 1/2 power. I'm actually going to write that in a different color here. Okay. Let's keep going. So we have another 1/3, another square root. We have a 1/2, and we have a 1 over x. So what about 1 over x? How can I write that as a function? Or sorry, as a exponent? Well, if you remember, 1 over x is also known as x to the negative 1 power. So I would use x to the negative 1 as my function there. Since we have enough room, let's do another column. Okay, again, number 7, we have 1/2 and 1 over x. Then we have 1 over x squared and 1 over x to the 3rd. So those are pretty straightforward as well. 1 over x squared can be rewritten as x to the negative 2 because it's a reciprocal. And of course, 1 over x to the 3rd can also be written in a similar way. It can be written as x to the negative 3rd. More of the same in number 9. Number 10, 1 over x and x plus 5. Same thing there, same thing there. That's pretty much it. So just to be clear, everything needs to be in exponent form. So because what you're going to be doing, for instance, is let's say I have f of x is equal to x to the 1/2 power and g of x equals 1 over x to the 3rd. So what would I do in this situation? Well, first thing I want to do is I'm going to convert this into x to the negative 3. And then when I go to do the actual f of g of x, this is what you're going to do. I'm going to write it this way. I'm going to put a parentheses to the 1/2 power, because that's what this looks like, because I'm going to take this and I'm going to put it in here for this. So inside of there, it's going to be x to the negative 3. And the reason we do it this way is because we know that when I actually work this out, these two get multiplied by each other, negative 3 times 1/2. And so the final result will be x to the negative 3 over 2, which could be rewritten as 1 over the cube root of x, or the square root of x. But actually, you know what? We're not going to talk about that way, because I believe the answers are going to look like this. So that would be my answer. So you can see that once you convert everything into exponents, it's just a matter of multiplying the exponent on the outside of the parentheses by the one on the inside of the parentheses. So that's really what this lesson is all about. Quick tip: this expression can be rewritten as x minus 3 squared. That should help you as you go about doing that one. So again, this can be rewritten as x minus 3 squared. So use that when you go to work it out. And then we have some review questions. Remember that when you find the equation of a circle, it's in the form x minus h plus y minus k squared equals r squared. So then that means that this should be r squared, and the values in these positions represent h and k, which are the same as that point right there. So you should be able to plug those in and get that answer pretty easily. And then finally, in number 15, you just need to basically do this times itself 3 times. So you'll have to FOIL and then get an answer and then FOIL again. So that's how you do those. And that's the end of the lesson 9 video.